And we're live. I hope so, we're live. Yeah. So, hey! Thanks, my best buddy, Fabian Lars. Let's have a mate. I need that to what I'm about to do. Let's put some music. Yeah. Returning the wrong part. Hey, Daniel. Okay, so let's get going. Last time that we ended, we had everything kind of working, but Rust is not doing anything. So this time I promised I would face every possible fear and get on with Rust. So let me adjust my screens over here and I'm good to go. So and let's start showing some code. There we are. Yeah. So this is our code base. We can stop this for now. And our main hi Etheria. And so we have the source Tauri here and it's pretty empty. At this point, we just have the get dir data that's doing basically nothing. And we have essentially the default Tauri stuff, except with the invoke handler, which is not quite in the boilerplate. No, actually, it is part of the boilerplate anyway. So let's get started with the rest. At this point, I think the most important one is to get started with the error, with the error management in our Rust code. So we'll create an error RS where we can do then we can start creating the macros to handle our errors. Let's go with that with using our crate, and we're gonna go with the folder stat crate, and we are also gonna grab serde because we need to serialize the data, and we're gonna need the serializer for this one. So what this is gonna do is basically some boilerplate code, more or less, where we're gonna create a public enum for errors, and this is just gonna be this enum that takes every possible error, and we're gonna use this macro for the debug that's gonna allow Rust compiler to pick the error that we're bubbling up and use our custom error handling. So, and to actually have it working for the serialization part, we need to implement the serialize support inside our error macro. So this is more or less common in every Rust code that handles serialization because it's not part of the crate itself. So we're gonna take the serializer and it's gonna bring back a result which is either gonna be an OK or the serialization error. Where S is the serializer, and then we get in here our serializer, and we're gonna string serialize the string. And I think I'm missing my crates over here. Let me check one thing. I need to actually bring back my status bar. And yeah, this file is not part over here. Let's see how it's okay. We have 30, we don't have the file stat. Let me check here. I'm missing quite a few that we're gonna use. So actually we should start by this. So we're gonna need Tauri specta that we're gonna use in a moment. And we're gonna need quite a lot actually. So let's see. Specta, this error, Tokyo, and regex, glob walk, and features. Awesome. Okay, so now we have a few of these dependencies that we're gonna need, and we need first to implement our folder stat actually, because that's not coming from a crate. That's something we need to use, and folder stat comes from the util, and that's why it's this problem. So let's create a new file, and this is the last one we're going to create. So we need this first to derive, oops. From serialize, type and debug. And then what we want is a public struct that we're going to call folder stat. And then this is gonna be a path buffer, and the size, which is gonna be a U32. Awesome. So this is the first part. I'm already gonna add a few other methods here that we're gonna use, and they're kind of they're a little bit less involved with the logic. They're just like formatters and stuff. So this one is going to be the order list, so it gets out of the way when we get to need it. This is going to receive a vector of our folder stat, and it's going to return exactly the same thing, because as the name says, this is just for sorting. So we're going to take the sort by method, and what we're gonna do is we're gonna take the A and B as a closure, and we're gonna take the comparison of these two. So at this point, A path compared to B path, of course, and as the second one, we're also going to have a closure that's going to compare the size of B to the size of A. And remember, good note for JavaScript developers over there is that if you don't put your semicolons, you're going to return the thing. So we need to add a semicolon. So what this method is going to do is it's going to order them by size, and if size is the same, it's going to order them by path, or in the way, order first by path and then put the size ones first. So this is good. And then the last method of these utils is going to be to get the data from each one of those folders. the size of each one of those files, which I'm gonna leave for last, because that one is the most complicated one that we have. So let's leave it for later. Maybe we get some extra people here. So now what we're gonna do is back into our error, and let's start adding some error handling here. So the first one is gonna be the error for Tokyo. So if the stream we're about to implement in the IO does not work, we're gonna grab the error from the IO from Tokyo, and we're gonna create our own messaging. So this is yeah, and so this is one, the other one being let me copy paste. There's a big string over here. So the next one being when we have an error passing down the statistics from our files, and then we're gonna grab this error as well and pass this one, because Tokyo error is not very helpful to us. And then we have another error in case the node modules, which, yeah, this one is better, like this. So if the node modules folder is too large, we're gonna pass down an error as well, because we don't want our code link. And with that, we have our errors prepared. We can now handle serialization errors. We can handle if the file is too large, and we can handle if anything else goes out of the ordinary, and our code cannot deal with that. So that being said, we have now here we can create our most gnarly one before we start calling them. So back over to our utils, we are gonna start creating the get size. And the get size is one method that actually exists in a crate called fsextra. And the problem with that one, and the way, hey man, how's it going? So yeah, I'm about to code that gnarly method that we saw on Ryan's stream, which is using some lifetimes, it's using some future. So why are we doing this? So there is a crate called fsextra, which is pretty awesome, to be honest. Let me show you this. So back over here. So let's go docs.rs fsextra. So this method is pretty great. It has some nice way of introspecting about files, about folders in our file system. We can come over to directory, I think it should be, no? Hey, Danielle. So this one is actually allow us to get the size. And this method is exactly what we need. We pass a path to it from a directory. It's gonna recursively grab the size of each of our files and then measure them up and bring back a size in bytes for our directory. Exactly the way we wanted to do. And then my first implementation of this code, I actually used this get size crate. The problem is this method is synchronous, and then because node modules are, well, essentially a black hole, and they take absolutely everything that you can imagine, and they can be gigantic, this made even Rust slow. So it was taking too long. It was taking way too much time to handle. So what Jonas, my colleague and essentially a human Rust compiler, figured out is that the first way to make this code unblocking and to make this code faster was to create or to get a way of parallelizing the the getSize method. So in order to do that, we had to go in and essentially grab the source code from fsextra and make an asynchronous version out of it, which proved itself to be extremely complicated. So let's see if I can walk you through this. So the first thing that's gonna happen is, as you can see here, we have this little tick over here. This indicates a lifetime, and this is one of the last parts of Rust that this is not inferred by the compiler. So what happens is, because we're gonna deal with asynchronous code, we need to define for how long a value is gonna live in memory. And I'm actually saying, okay, so this value, though it's not defined in this particular method over here, we're getting it from somewhere else. This method is gonna define, this scope is the one that's gonna define for how long this method lives. So do not drop this value until this code is done, because Rust is not able to infer the time a value should be held in memory if the scope is asynchronous. And that's what we're doing. We're saying, okay, so this param here is gonna live in memory for as long as I need it to. So this param being a borrow, so it's a reference to an existing value of a path. So essentially it's just a path string, but then that's how it goes. And now we need to annotate the value, we need to annotate the return type of this method. So the first thing is we need to pin it, and then we need to box it as a value. And then whenever you have a promise, talking to the JavaScript developers over here, whenever we have a promise, we need to define that the type of this promise is dynamic. And a promise in Rust is called a feature. So once that is done, then we can type the output of this feature. And the output is going to be a result. This result is a special type in Rust. It means that it can either be a success or a failure, essentially. So the first one is going to be a U64, which is a number, a type of number, or an error. And then over here, we need to do this weird stuff, because then we are sending it over to back upwards to wherever the stream was initiated. So essentially, yeah, luckily, Daniel, I have no idea what you're talking about, because I never touched Kotlin code. But essentially, Tokyo has this send method where we're gonna send things back to the main thread. So that's it. So now I'm gonna copy my comments from the code. So here is the thing. Like, if you want to map it back to how it works on the fsextra crate, you can. So this uses the symlink metadata, because we're not following symlinks in this particular case. So what we're gonna do is have the path metadata, and this is gonna be Tokyo fs, and this is gonna grab the symlink data, passing our path, and then we're gonna await. So we're grabbing the path of the metadata, and Tokyo, if you're not familiar with Rust, Tokyo is the de facto gold standard for handling asynchronous code or streams in Rust. There's like, I wouldn't be able to tell you the difference between multi-threading and vanilla Rust, if I can say that, and Tokyo. I know that there are differences, I just cannot elaborate the differences. Yeah. So let's keep on going. So we have that, and then we define a mutable that's gonna be our size in bytes, and that's gonna be 0 for the beginning. that's it. Do I need to annotate the type? At this point, it should be grabbing the types. Yeah, let's see. Awesome. So then now we have an if, and then if we have the metadata as a directory, we can create a new mutable that's gonna be Tokyo FS, and we're gonna read the directory that we're passing. Here we go. Okay, so, and then finally we get to the iterator. So we're gonna grab, like, whenever we find an entry, we're gonna evaluate that entry, and if the next one is, then we're gonna dig in. And now we're gonna grab the entry metadata if it's a directory, and then we're finally gonna call the synchronous get size on that. And then we're gonna sum up, because remember, we're going file by file and we're adding that to the dir. So this one can be synchronous, that's totally fine. If that doesn't work, if that's not a directory, then we can add to the length. We can add to the size in bytes. And where are we here? 1 second. Else. And then we can close the sum. Awesome. And then we have another else over here. And finally we can return the size in bytes. What happened here? Did I miss? I missed a curly brace. Where did I miss the curly brace? So, path data, bump, and then while this one goes. Oh, yeah. Entry metadata. I skipped defining the metadata, which can be problematic. Then we define the size in bytes, and else is here. This one is not. Okay, so it was here. I needed to close our iteration before this one, which makes total sense. Awesome. So with this, we are now able to say, we are now able to measure. We get to measure the size of each directory. And then now we need to get the names, because remember, we're gonna pass a scope. So we're gonna pass just the file path, the root file path, and we want to find all the possible node modules in there and then clean up the list and then go forward. So we need to also define a new public method that's gonna be the getDir names. And then this one is gonna receive a borrow, that's a path, and it's gonna return a list of paths, of path buffs, and essentially. And we're gonna define the file names as a new vector. And then let's define the walker, which has that name from the crate, which is the build walker. Does it work like this? Oh, okay, there. See you in a minute. Yeah. Call me up if you're watching and something doesn't make sense or add up. This is why we're not getting the autocompletes. Hey Victor, all good, all good. So you just missed me getting into a fight with this one over here. So we turned the fsextra synchronous method into an async get size. So what we did essentially is turning into a future and putting that into a Tokyo stream. Once that is done, we go inside and find each directory and call the get size on each of the files of this directory and sum it up, and then we come back with a number in bytes. Now that we have the get size, we're implementing the get directory names, which are the first method that's gonna grab our path from the scope and bring back a list of files. Before that, we implemented the errors, which is pretty much quite a lot of boilerplate, to be honest. So we're creating some macros to handle the errors that are gonna bubble up. So we went to deeper down and we're coming back up to the point where our Rust code is gonna meet with the SolidJS code that we have in the front end. So now I'm creating the Glob walker, sort of. It's, in my opinion, it's a horrible name, but it's coming from this crate over here. Why is it not included? It should be included. I already added the crate. Let's reload. No worries, no worries. Oh, that's amazing. That's great. Oh, I want to play with Torso. I want to play with Torso as well. Let me know your thoughts on that. Elysian Lucia, I don't really know what that is, but I'll make notes for it. Yeah, I want to see that. If you have anything that's open source, grab me up and let me look. That's amazing. Ah, Lucia Auth. Okay, heard about that one. Yes, now it rings a bell. What do you mean Glob Walker is a Jedi, Victor? Is it? Have a nice meeting, man. See you in a minute. See you later. Is Glob Walker a Jedi? Because it's Skywalker? Oh, no. Seriously? Now I like the name. Can't believe I missed the pun. Okay, why is it not working? I have Globwalk here. Did I put Globwalk instead of Glob Walker? Is that it? Did I fumble that hard? But I let me see in the docs what it's supposed to be. Oh, better yet, let me see in my code that actually works. Where? Cargo Tomo. No, it's Globwalk. It's quite the same, yeah. That's funny. Tokyo is actually, yeah. I'm glad I have people like Jonas that make pull requests to my code, because they make my code so much better. Tauri specta, actually I need to add the features JavaScript. So it's, we don't need to add more than we actually need. But glob walk is okay. Should be working. Let's see if I need to. Let's get it running. See if it ends up whatever it needs. Yeah. Let's compile one time for good. Okay. Why is it not here? Let's keep writing. Okay. So what we need now is from, it's not auto-completing. I'm so put off by it. No, use globwalk is fine. Yeah. Awesome. Okay, so let's go for it. Now we're gonna create our walker, our little Jedi. I like that. I like that a lot now. Glob walker builder, and then we're gonna get from the patterns. We take first the path, and then here's the thing. We're gonna make this very ugly looking blob that doesn't so oops. So this is a borrow of an array, and it's not a vector because there's a difference in Rust. I know for just JavaScript developers they're all the same, but the thing is, an array has a defined allocation memory. So this means that the array goes, this means that a vec goes to the heap. So there's like pretty much no size. It can take as many length as it is. And when we define an array like this, it's not growing any longer. So an array has a limited size. There we go. And now we can define like the max length of it, and we're gonna define it to not follow any links inside, so no symlinks. We're gonna build our array, and here's the moment I'm actually gonna do an expect, which if you're more familiar with Rust, you know that's not the best thing you could do, but at this point it's controlled, and we want it to we want to move a little bit faster on this, so we turn it into an iterable, and we're gonna filter map or only the results. So with that, this is how our code is gonna look like. So this is our walker. This is gonna bring us back. What does it really bring us back? This is gonna bring us back an iterator that each part of it is actually an entry result. So for this, we're gonna take the file and inside the walker, and we're gonna walk through them. So we take the path string, which is the file path, and we're gonna use the display method to convert it to readable, from buffer to readable, and then we put it as a string. And then we need to create this node modules regular expression, and this is the part of the code that doesn't look exactly great, to be honest. So I need now, because we're gonna need to trim down repeated node modules inside this regular expression. Let me see, did I add the regex? I don't remember doing that. Yeah, I didn't. So we are gonna need a new one over here. So let me open it up again and go into our source. Tauri. Hey Cassie, how's it going? Going to the source Tauri, and we're gonna cargo add regex. Okay. And whoop. Oh, I got a version newer. Let's see. Pop. Okay, so now we have a regular expression here, and with the regex, where are we? So now we're gonna have a little bit. We need to clean up, because what's gonna happen is the glob, and I think I'm talking mostly to JavaScript developers right now, right? So the globs in Node.js are way simpler to deal with than the globs in Rust, because my initial attempt of writing a glob was I wanted to have something like this, for example. So I wanted to grab everything, a node module inside every possible folder, and then here I wanted to not grab any nested node modules. Oops. I wanted to grab no nested node modules or something like this. I think it actually should be this, or yeah, I don't really remember, but essentially I wanted to exclude every nested node modules, and this doesn't work in Rust, because both the glob walker and the actual glob that's a crate that has even more usage, every time you create this double star, it becomes like super greedy glob where every subdirectory is included. So there was no way with just like, or at least no way that I found out with plain glob, with just a clever glob to just exclude the nested node modules, which was essentially making my code run forever, because every dependency inside my node modules would have their own node modules, and then it would never come back, or at least it would list dependencies inside my result list. So we're gonna do is we're gonna create this count, and we're gonna create this mutable start, and we are gonna create this should scan that's gonna be a boolean, and we're gonna actually start with true, and that's gonna help us define if a file path should be scanned or not in this case. So we're gonna check for the matches, and the node modules regex is gonna capture, and here we pass the haystack for our path. It's gonna be everything is gonna be it's gonna be what's passing in inside the match, and then we sum up the count, and we sum whatever is coming to the end of it. So if our count is higher than 1, we convert. We're not gonna scan, because we're essentially counting how many times node modules are gonna match inside the string we're passing. So then we convert should scan to false, and we can break out of the loop. So we essentially stop iterating then. Once that is done, we can check if this folder should be scanned, if this directory should be scanned. Then we have a new file names vector, which is the first one we're defining over here, and we can push our path. And we're actually converting to path buff again, so we have a more a smarter usage of memory in this case. And that's it. Oh, yeah, sorry. We need actually to return the file names in the end. And that's it. So basically what we're gonna do first is we get the directory names and we create an empty vector. We instantiate a glob walker. So once the glob walker instantiated with the path that we received from the front end, we define, yeah, the max depth is gonna be 6, which is a pretty high number, but ideally I'd like to make this configurable on the front end eventually. We define it to not follow the symlinks, and we turn it into an iterator. Once that happens, we go like one by one. We convert the path from a buffer to a string. We create our regular expression. We are gonna go through each one of those, and if we count the number of times there are the term node modules inside. If it's more than one, we decide to exclude it because that means it's a nested node modules. If it's less, if it's one, essentially, or less, but it's gonna be at least one, we add it to the path buff. So we add it to the file names, and this is gonna return the vector to our main function. So now let's code our main function. So here is the main, essentially, as we saw in the beginning of this stream in the past ones. This is mostly Tauri defaults at this point. So if you run create Tauri app, you're not gonna get the get dir here. You're actually gonna get a greet method, and then it's gonna pass the invocation handler to your front end like this. But then the rest is just like completely default. So we're instantiating the Tauri builder. We run the Tauri builder with the context, and if something happens, we're just throwing an error, an exception here. What we're gonna do now is actually code the rest of this get dir, and then we're gonna add the types to specta and stuff like that. So that's gonna actually generate the types where we want them to. Awesome. So now besides this, actually, we are already gonna, I can leave the specta for later. So let's create a Tauri command. So first of all, this method is actually gonna become an asynchronous method. And it takes the pattern as a string, and it's gonna return a result that's gonna be a vector of folder_stat and or an error. And folder_stat is actually not being imported, so let's go and grab folder_stat over here, and and the rest is for Tauri specta. We need actually to declare the modules over here, and everything broke because, yeah, I'm sorry, this should not have gone here. Awesome. Why? Ah, yeah, so that makes sense for now. And because we're not actually returning, so the type annotation that I just created is false at this moment. So let's delete this and start coding. So the directories are gonna come from this, and we're gonna use the get dir names. We need to actually do some conversion over here. This is gonna be a new path from this pattern. Awesome. So do I need to import path? Why? What's going on? Use of undeclared path. Where does it come from? It's stood out. Oh yeah, I totally skipped a step. Okay, so yeah, that's good for now. And then we need to create an iterator that's gonna iterate through our directories, and we're gonna map. Inside this map, we pass a closure. You're also quiet over there in the chat. Are you? Did I completely lost you, or is it surprisingly everything's making sense to everyone? Okay, so we go through the iterator, and let's get a size. This size we're gonna take a try from the number, and we're then gonna pass the get size method, and we pass this one, and we need to await. So now we are converting the size into a number, or a U32 in this particular case. And finally, we can call the OK method. If everything worked, we turn into our very beautiful tuple, and we assert that this is gonna be a folder stat or an error. Finally, we're gonna get the result, and we're gonna try to join all of the iterables, and then we're gonna order the results. Try and join all is not in this scope because I didn't import it. So let's go back over up here, and I'm gonna use from futures, I'm gonna use future, and then I can use try join all. And then I can use error, and that's about it in this case. Yeah, so now that we are good with that, we can start defining the types. So let's go with types. Let's go with specta. So specta is this method that we're gonna use to generate. It's a crate that's gonna generate TypeScript types from our Rust type annotation. So what we're gonna do essentially is grab our Tauri command, and we're gonna wrap it into a specta macro. With this one done, we can use the TS method from Tauri specta, and we actually need to import the collect types method from specta as well. Why is it unresolved? I have it here. Oh yeah, I have Tauri specta, not specta. There we are. Okay. So with this out of the way, we can come over back to our main function. Inside the main function, I'm gonna call this macro called config debug assertions, inside it, I'm gonna use the TS method to export these types. So we need to collect the types from a number of methods. So being this one, the first one, I actually just need to pass the method name. And then I need to define a place where this is gonna go. And finally we unwrap it. So, yeah, this doesn't, yeah, awesome. So the export path is actually gonna be in source, and we're gonna call it Tauri commands.ts. So now, once I save it, and then I can start, when I start the process for building our Tauri app, what's gonna happen is every time the main function calls, it's gonna run the Tauri build, and it's gonna create this Tauri commands.ts file inside, actually instead of being inside my library folder, with all the types, so with all the type safe methods. Why do I have a red line over here? Let's run it. I think are good to go. Let's see. Let's see if something breaks. Oof. So we have mismatched types. I skipped a bit on the get size. Yes. On the get size, there's something I fumbled. Let's go back to it. Get size, get size. There you go. Bunch of bad things happening over here. So let's see. We have our get size that has a lifetime. The pin is actually complaining. Why is... Yeah, this is because of we're not returning the proper thing. Let's see. Oh, yeah. So that makes total sense because I'm actually not pinning. Yeah, so okay. So yeah, I forgot just to move everything in. Yeah, there we go. Awesome. So this means I could theoretically run our stuff. So it's scanning. And did we skip the beat on this? Did everything? Is everything ready? Handle promise. Yeah. So we need to actually use those things. So good to go on the Rust side. Sounds awesome. So let's check how our stuff is. First, let's see our Tauri commands. Look how beautiful it is. Yeah, we have everything that we needed. And we can come over here to our app. Results table is actually missing some stuff apparently. Let's go to results table. Quite a lot, to be honest. We don't need that. We need this, and then instead of this thing over here, we actually need to go into lib and Tauri commands, and then we have the folder stat. We can bring everything else back. What else is... Oh, wait. What? Delete modules is here, table row is here. We didn't implement a results table. Okay, my bad. Results table. We have the table row. And let's now create our proper results table. So we have some list props that we need to define first. And the list props is actually made of the folder list that is an array of folder stats. So we have the list props down here, everything defined, cool. Now the results table. And let's put some boilerplates over here, which is first the table tag, and then we're gonna use the transition group. Let me close the table and also the body. Transition group can be closed as well. Inside the transition group, what we're gonna have is a for, oops. And inside the for, inside the for, we're gonna have the folder list. Import it. And because these are static, we can just destructure them like this. Our little arrow function. Yes, okay, this is good for now. And then if we have no path, we're gonna return no. Otherwise, we're gonna get the directory name from the path. And if the directory name is null, again, we return null. Otherwise, we format the size of the node modules. And then we return the table row. And then the table row is gonna take the module size, the directory information, and this should be good to go. Back over here. Wait, what? Why? Cannot find type declarations. Oh, there's no file? Okay, we need a few extra files in our library. So we need the get directory, which is essentially just a big regex where I'm gonna split out the node modules, take whatever comes before and the actual file path. And we have also some formatters. So essentially the format size unit, I'm just gonna take the byte size, make sure it's right, we truncate it, we append the unit, and then it returns a string. And we need to also apparently add the solid transition group to our dependencies. Get their name didn't work. Why not? Let's go to get directory name. Okay, now it should work. Awesome. So now Tauri dev. So now it's gonna compile everything, and there we go. We have our work, and let's try to scan my crab nebula directory. It should take a few seconds. Let's see. Got your... Oh, wait. Why do I have dear data with a capital? What's going on? Where in the scanner? It's not like this. It should be data like this. And this is not correct, actually. We actually want to change this thing over here. So the get dir data is not remotely similar to this. We want to... Yes, this is actually what we need. Yes, yes, yes. And we don't need these errors anymore. So, no, we don't need this one because this was abstracted away by Tauri specta. So this is where we're calling the invoke. So that was like some monkey patching code that I did. Let's run this again and go for it, go for it. Yeah, so again, let's grab my crab directory and we already see, oh, why? It already finished, so cannot find variable results table. What did I do now? Let's go back to our app. Results table is imported and it's missing our list props because our list props should be coming from scan data file list. Is that it? Let me double check. Yep, that is correct. So why are you complaining? Oh, that's probably on the store definition. Are we missing something over here? Yes, we are. Because this is not correct. I need to import this from specta. And now everything should be all right. I can actually see how long did it take to load things. We can actually change that to our scan data stats actually. So let's go back here, scan data dot stats. So now we're back and now it's gonna work. Otherwise I'm gonna get very annoyed. Back to it. There you go. Yes. So we have everything working from SolidJS to Rust, passing by Tauri specta. Oh, Vitor, thanks. Yes, we got it. So that's what I had planned for us today. We did all the 6 directories in 164 seconds. Let me show you where the actual code for this is, so you can have a look if you want. As you can see, the codes, the app itself is not final. Now we got to the same, Now we got to the same stage where we were before. on the Rhine stream and where I am basically in creating this app. So there's no like idle state exactly. It's just this horrible waiting for results. If we do something here to search, it's just like scanning. So yeah, if you wanna help out, you can come over. Well, you can come over here and help me out. Let me show you where it is. I'll put the link. So yeah, this is the final link that we got, and that's it for now. And thank you for coming, Victor. Thanks a lot for staying all the way over here. And yeah, let me know. Grab me on X, or yeah, let me know if you like this one. For the next week, I'm still planning some stuff. So if you have any ideas of stuff you would like to see, if we could start a new app, if we could go on further into this or something else, let me know and I'll be happy to do that. So thanks a lot, Victor. Oh, thanks a lot, Litheria, and I'll catch you all on the next one. Bye bye.